In this lesson, we're going to start looking at how to prove similar triangles. So one way to prove that two triangles are similar to each other is to use what we call angle-angle similarity, or as a shortcut, you can write AA with the similarity symbol. So this is what this really means is if you have two sets of congruent corresponding angles, then the two triangles must be similar to each other. So you don't have to show the third angles, just because if all three angles in a triangle add up to 180, and if two sets are congruent, well then the thirds have to be congruent as well, since they all add up to 180. So what that means is instead of saying AAA, we can just say angle angle. So we only have to prove two pairs of corresponding congruent angles, and then the triangles are similar. So if we look at this example, we are trying to prove triangle JKL. So JKL, we want to prove that that triangle is similar to triangle JMK. So JMK. So the first thing we want to think about is our strategies when we're dealing with pictures like this, where we have overlapping triangles. And if you think back to when we did our congruent triangle proofs, we want to now focus on getting these in the same position, redrawing them, separating them so we don't see the overlapping, and then we're just looking for two pairs of congruent corresponding angles. So the first thing I'm going to do is let's just redraw these. So if I look at the small yellow triangle, and then if I compare that to this blue triangle, I'm going to rotate that so the right angle is in the same position. So let me get my letters on here. So if I look at this, this is going to be J. I have a right angle here at M, and then K. And then for the large triangle, this is going to be K. J is going to stay down here, and then L is up top. And again, if you look right here, J and J match up, K and M match up, and L and K match up. That's how, again, I can look at that to kind of help me when I turn my larger right triangle so that they match up. So what I want to do now is I want to focus on getting two sets of congruent corresponding angles. So right away I see these right angles in there, but for the right angles we need to actually mention them because what's given to us is the perpendicular. So remember, we can't just go to right angles, we have to go from perpendicular lines to saying we have right angles to then saying that they're congruent. So let's start with our given. So I'm going to do a flow proof. So we have perpendicular. I'm just going to go ahead and group these together since they are going to give us the same conclusion. So this is given. And then from here, I'm going to talk about those right angles. So I have angle JMK. So JMK. And angle JKL. So JKL. So I'm using three letters so that it's still, I'm talking about the same angle in my separated picture versus the original. So angle JKL are right angles. And my reason for that is because we were given the perpendicular lines. So perpendicular lines imply right angles, or perpendicular lines and form right angles. And then from there, since those angles are right angles, we want to say that we have congruent angles. So since they're right angles, I can now say angle JMK is congruent to angle JKL. And I want to go that route because remember, I'm looking for angle-angle similarity. I'm looking for two sets of congruent corresponding angles. So I can say all right angles are congruent. So there is one set of angles. So I have, here's a set of congruent corresponding angles. So I can mark this as complete. And now I need another set of congruent corresponding angles. So if you remember, whenever we have overlapping triangles, look for reflexive property. Look for something that's shared. So in this situation, we're not going to be looking for a shared side because the size of the triangles are different. The sides have different lengths. So that means we're going to be looking for shared angles. So when I look at this original picture, I see the colors changing right here. I see angle J is in both angles. So angle J has to be congruent to itself. So that's going to be the reflexive property. So I'm going to go ahead, and you could really just use one letter here since there's only one angle J. So angle J is congruent to angle J. And you could use 3 letters too. That would be perfect as well. So that's by the reflexive property. So that gets me my second angle. So by angle-angle similarity, now I can say that the two triangles are similar. So it's a very short proof because you only need 2 sets of congruent angles, which I have. So now I can say triangle JKL is similar to triangle JMK by angle-angle similarity. We have both sets of congruent corresponding angles, meaning the triangles have to be similar. They're the same shape. And remember, we don't have to prove the third angles because all 3 angles add up to 180. If these 2 sets are the same, then the thirds are also the same since they all add up to 180. So that's why it automatically happens. So the shape's automatically going to stay the same. The figures are similar. So that's it. So go ahead and check your understanding problems. You're going to be using angle-angle similarity. So all you're doing is looking for 2 sets of congruent corresponding angles, and once you have that, you can say that the triangles are similar by angle-angle similarity. Just be aware that this wouldn't be enough for quadrilaterals or pentagons or hexagons, not for any polygon, because you have to show all sets of corresponding angles for those figures, or at least one less than the total amount of angles. So the reason why we only do 2 here is because there's 3 angles and they all add up to 180, so those thirds are the same. So just be aware of that. Okay, so this only works for triangles, angle-angle similarity. So go ahead and do those problems.